addition here. A tempting thing to do right here is just to solve this for x. It wouldn't be wrong, but I'll let you be the judge on what the best approach is. From the well-known quadratic formula, we get this statement that x is equal to 3. Remember, negative b plus or minus the square root. Now, y'all, I'm going to go ahead. It's b squared minus 4ac. I'm going to just go ahead and write the result down. That ends up being 141 in the radicand. Okay, all over the understood coefficient of x squared, which is 1, 2 times 1, 2. Okay, now an approach here, and not an invalid approach, would be just to take each of these values, 3 plus these conjugate surds, sometimes they're called, and substitute it into this expression x minus 8 plus the quotient 7 over x plus 5, okay? Now, it wouldn't be so bad right here, but it would be a little bit of trouble to do it right here. So it turns out there's a better, not surprisingly, more elegant approach here. What we do is we take this expression. Now, this step right here, I think, when I was learning math, this step would get, the teacher would just not write this down, you know? But what you're doing, it's very useful, very, very useful to multiply by a cleverly disguised version of 1. I've heard it called that. Okay, so notice that circled object is just equal to 1, right? Nothing wrong with multiplying something by 1. That's a multiplicative identity. But that leads to a very favorable outcome right over here. Let me come over what we end up with here when we FOIL this out, when we expand x minus 8 against x plus 5. I'll just write the result down. We get x squared minus 3x and then what do we get there? Minus 40. But the nice thing about all this is that we've created a common denominator from our previous step. Now that's going to be plus 7 right there, right? Plus 7. And because of the nature of this previous step here, we have kind of a built-in common denominator. Okay. Y'all notice a nice thing happens right here. You see this minus 40 and this 7 becomes negative 33, which is actually this initial condition, which a lot of you probably just saw from the word get-go. But so let's come down here and just finish the problem off. So we end up getting an equals. And again, I'm just recopying with the simplification in the numerator. Okay. X squared minus 3x minus 33. Okay, minus 33. All over x plus 5. But notice that's exactly our initial condition right up here. See, we know it was given to us that this object is just equal to 0. Okay, that's equal to 0, and so what we get here, this is certainly equal to 0. 0 divided by anything other than 0 itself is 0, right? So that's our answer. It's a little unsatisfying, you know, because you're thinking, oh, is it always that way? Well, for these kind of problems, probably, but they kind of have to be constructed. But just imagine how much labor it would have been to take. And what's interesting, if you take both of these, 3 plus root 141 over 2, and put it here and here after some, let's call it involved arithmetic, you'll get 0. And also if you take 3 minus. So this kind of hides the fact that doing it this way would involve 2 evaluations, and both of them do evaluate to 0 by necessity. But anyway, I hope you guys enjoyed that one.